Hello friends, welcome back everyone to this channel. In this video we're going to see how do we solve the linear programming problems. Okay. Before the questions we have to know some of the things. Okay, so what we have to know, what is the objective function, constraints, non-negative constraint, feasible region, feasible solution and optimal solution. These also can be asked as a definition one in the 1 mark part. Okay, first, what is the objective function? Objective function is nothing but this one. This one is the linear function, that is x is equal to general form, z is equal to ax plus by, and which has to be either maximized or minimized. They'll only give in the question, and here they have first question they have given to maximize it. Okay, then constraints. Constraints are the conditions which are imposed on the variables x and y in the form of inequality. Okay, then what are non-negative constraints? These two are the non-negative constraints: x greater than 0, y greater than equal to 0, x greater than equal to 0, y greater than equal to 0. This both togetherly known as non-negative constraint. Okay, so let's get into the problem. First step to do here is, first maximize the objective function and constraint they have given. Here only one constraint is given. First step to solve this is, first take a constraint which is x plus y less than or equal to 4. This is in the form of inequality. So change it to be an equation. An equation in sense, this inequality sign changes just to be equal to. So x plus y is equal to 4. Okay, we have taken an equation. Now we have to find 2 points to draw a line in a graph. Okay, so x plus y is equal to 0. 2 points we have to find. Just take one as y. If x is 0, so y will be 4, and if y is 0, x is 4. Okay, we have found 2 points. Okay, we have found 2 points. Now we have to draw a graph. You can also use a graph or you can use your notebook only. Okay, just for solving I'm taking my notes, but you have to use your graph in the exam. Okay, so this is x-axis, y-axis. We have to write the scale to x-axis, y-axis. Now we have to take the points. So it is ending just at 4, so we can take 1 to 5. 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. Okay, now 0, 4. So this is 4, 0, and this is 0, 4. Now join these 2 points. Minimum we have to take 2 points. We have to find 2 points to draw a line in a graph. Okay, so that's why I have just taken 2 points. Okay, now 4, 0 and 0, 4 are the 2 points, and we just have to represent what is this line. This line is x plus y less than or equal to 4, but this is not this expression, it is the expression for x plus y is equal to 4. How do we get this? So now we have to take in testing point. Testing point for these type of lines, either we can take the origin or the point which is this side. Okay, so I'm just taking the origin. Testing point TP, which is 0, 0. Then substitute this in this equation, x plus y less than or equal to 4. If we substitute 0 plus 0 less than or equal to 4, 0 is less than or equal to 4. If it is true, then the feasible region is towards the origin. Okay, so this total region is the feasible region. Okay, either you can draw like these lines or you can just put an arrow mark to show a feasible region. Okay, now we have gotten it true. If we didn't get it true, you just have to take the other side. Okay, then we have found the feasible region. So feasible point is 0, 4 and 4, 0. Now these are the 2 points. Okay, we have to take these 2 points, 4, 0 and 0, 4. We have to substitute in these equation in the objective function to get which is the point where it get maximized or minimized. Okay, so we have got 2 points, that is A, B and also C. C is actually another point, 0, 0 origin. Okay, So z at A in sense at the point 4 comma 0, 3 into 4 plus 4 into 0, which is 12. Z at B, which is 3 into 0 plus 4 into 4, which is 16. Z at C is 3 into 0, 4 into 0, which is 0. Okay. In this 3, which is the maximum value? Maximum value is 16. Therefore, it is maximized at 0 comma 4. Okay. We have to write, therefore, the maximum value of z is 0 comma 4. Okay, maximum value of z is 16 at 0 comma 4. This must be our answer. Only so much is the steps we have to follow for a problem. Okay, next we are going to see the second problem. Second problem is minimize z is equal to minus 3x plus 4y subject to x plus 2y less than equal to 8, 3x plus 2y less than equal to 12. Okay, the same. First we have to take the constraint x plus 2y less than or equal to 8. This is the first constraint, and 3x plus 2y less than equal to 12. Second constraint. We have to convert these inequalities into an equation. Then 3x plus 2y is equal to 12. We have to find 2 points. So to find 2 points, x and y, first take x as 0. If we take x as 0, 2y is equal to 8. 2 4s are 8. So y will be 4. If y is 0, x will be 8. Now here also we have to find 2 points. If we take x as 0, 2 6. So y will be 6. Now if we take y as 0, 3 4s, so x will be 4. We have actually found 2 points. Now we have to draw a graph. So we have to take graph xy, and then we have to consider some points. So we'll just consider till 8. Okay, so if we have to consider till 8, 7 6 5 4 3 2 1, 8 7 6 5 4 3 2 1. Okay, so if we just draw these so much, and we do need to also write, we have to write the scale too. Okay, if scale is very important while doing the graph. 5 6 7 8. Now the point for the first line, let me just say this is line 1, this is line 2. And in graph, if it is difficult to write the entire expression, you can just say line 1, line 2. Okay, now x plus 2y is equal to 8. The points are 0 comma 4 and 8 comma 0. So this is 0 comma 4 and 8 comma 0. Now join these 2 points. If we join these 2 points, there comes a line. Okay, yeah, this is line 1. Okay, line 1. Now, and this 0 comma 6 4 comma 0, 0 comma 6 4 comma 0. Okay, here is the line which passes through these 2 points. This is line 2. Now the same, we have to take a testing point for both. Testing point for this first one is same, 0 comma 0 at the origin will take. Okay, so 0 plus 2 into 0 less than equal to 8. 0 is less than equal to 8, which is true. Therefore, the testing point is this one. So, feasible region of the first line is towards the origin. We can just draw a arrow mark like this. Okay, if it is confusing. And then for the second one, testing point, the same origin. 3 into 0 plus 2 into 0 less than equal to 12. 0 is less than equal to 12, which is true. Therefore, the feasible region of this second one is also towards the origin. Now we have to find the feasible region. Feasible region in sense, the region where the region which is bounded by all the constraints including the non-negative constraints. However, the non-negative constraint instance, it will actually lie in the first quadrant, and then the region we have to find where it is intersecting, like where all the both the lines are shaded. Okay, so if we try to shade, this will be like this, and if we try to shade this, this will be like this. So if we see, this is the feasible region of these constraints. Okay, so this is the feasible region, and now there are 4 points: O, A, B, C. Okay, O is 0, 0, A is 4, 0, B we have to find, and C is 0, 4. If we have drawn it through the, if we have used the proper graph, we would have got it directly. And even here, we are getting directly. See, draw a line like this. Okay, so it is 2, 3. But how do we get it experimentally or theoretically? If we see, first we have to take both the equation, and then we have to solve both the equations. So we can subtract both the equation. If we subtract, we'll get minus 2x is equal to minus 4. So x is equal to 2. The same value we have got here. And substitute in any one of the equation. I'm going to substitute in the first equation. So 2 plus 2y is equal to 8. 2y is equal to 8 minus 2 is 6. So 2 3s are, y is equal to 3. Okay. Yeah. X is 2 and y is 3. So the value we have got it. So there are actually 4 points to find. So Z of A, Z of B, Z of C, Z of D. Okay. No. O, A, B, C. So Z of O. Now Z of A. A is 4, 0. So minus 3 into 4 plus 4 into 0, which is minus 12. Then at B, 2, 3. Minus 3 into 2 plus 4 into 3 minus 6 plus 12, which is 6. Next, Z at C. C is 0, 4. Minus 3 into 0 plus 4 into 4 is 16. At 0, minus 3 into 0 plus 4 into 0. At O, okay. Which is 0. Okay. The minimum value here is 12. Therefore, it is minimized at these points. Therefore, the minimum value of Z is minus 12 at the point 4, 0. Okay. So we have found the point where it is minimum. And we are going to see the third problem. Third problem also we have to maximize. So Z is 5x plus 3y. Subject to, there are two constraints here. First, we'll consider the first one, 5y less than equal to 15 and 5x plus 2y less than equal to 10. Now, we have to consider the equation. One by one, we'll solve. Okay. First one, I have taken the equation. Now, we have to find 2 points, x and y. X, if we take 0, y will get 3. If we take y as 0, x will get 5. Okay. First one, we have found 2 points. Next, we have to consider the equation of the second one, and after considering, we have to find the points. If x is 0, y will be 5. If y is 0, x is 2. And we have to draw graph. Sorry, we have to draw a graph. Now, if we draw a graph, so the maximum point here is 5. So 5 is more than enough. Okay. So just 1, 2, 3, 4, 5. And same. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Now this line 1 and this is line 2. Okay. Line 1 is 0, 3 and 5, 0. This is 0, 3. This is 5, 0. So we have to join these 2 points. We have to join these 2 points this line is 3x plus 5y less than or equal to 50. Next, 0, 5, 2, 0. 0, 5, 2, 0. Join these 2 points. If we join these 2 points, it is line 2, 5x plus 2y less than equal to 10. Then is the testing point. Testing point for both the same, will take origin. Okay, so whenever we should not take testing point as origin, only one condition we are not taking the testing point as origin. That is, when the line passes through the origin, we have some problem in this exercise itself. The line just passes through the origin like this. Okay, so if it is in such cases, we should not take the testing point as origin, and for all other cases we can take the testing point as origin, and some all will be like towards the origin only few will be like uh, opposite to the testing point, like this side. Okay, yeah. Testing point is the main one. If we take testing point as origin, it will be towards origin. If we take anything, okay, if it is less, it will be towards the testing point. Okay, now testing point of now 3 into 0 plus 5 into 0 less than 15. 0 is less than or equal to 15. True. Okay, so this is towards the testing point. Now here also testing point is 0, 0. So 0 plus 0 less than equal to 10. 0 is less than equal to 10. True. Therefore, both are towards the testing point. This is line 1. We have to like write it separately. If you write for line 1 here, line 2 you just have to write here, so that there will be no confusion. Okay. Yeah. Now line 1 is this one, so which is towards the origin, and this is line 2, which is like this is not, yeah, towards the origin. If we see clearly, two arrow marks are pointing this side, and here this one is not pointing this side, so here it is not possible, and this one is not pointing this side, so here also it is not possible. So therefore this will be the feasible region. So if we say feasible region is this, so there are 4 feasible points. Okay, so feasible point A is 0, 0, and B is 2, 0. C will be somewhere here 1, 2, something like that only it will be. Okay, and then this one is D is 0, 3. Now we have to find the value of C. If we have to find the value of C, we have to take this. We have to solve this both equation. Okay, so 3x plus 5y is equal to 15. 5x plus 2y is equal to 10. Multiply this equation, the equation 1 with 2, and multiply the second equation with 5. So we'll get 6x plus 10y is equal to 30, and the second equation 25x plus 10y is equal to 50. Separate both the, subtract both the equation. So if we subtract both the equation, we'll get minus 19x is equal to minus 20. So x is, this minus sign cancels, 20 by 19. Then substitute in any one of the equation. So 3 into 20 by 19 plus 5y is equal to 15. Now 60 plus by 19 plus 5y is equal to 15. Then take this on the other side. So I'm just going to the next page. 5y is equal to 15 minus 60 by 19. Now 5y will be equal to 225 by 19 into 5. Y will be equal to 225 by 19 into y. Y will be equal to 40. Okay, 545. So 45 by 19. Y we got 45 by 19. Next, we have got 4 points. ZA, ZB, ZC, ZD. Okay, these are the 4 points. At the point A, it is 0. So the answer we are going to get as 0 only. 5 into At the point B, it is 2 comma 0. So 3 into, so answer is 10. Next, at point C, it is 20 by 19 plus 45 by 19. Okay, so the answer we are going to get as 100 by 19 plus 135 by 19, which is 235 by 19. At the point D is 0 comma 3, 5 into 0 plus 3 into 3, which is 9. Okay, these are the points we have found, and at which point it is maximum. As we can see, this is the maximum value among this. So therefore the maximum value of z is 235 by 19 at 20 by 19 comma 45 by 19. We have found the answer for the third question. Now we are going to do the fourth question. Maximize z is equal to 3x plus 2y and subject to x plus 2y less than equal to 10, 3x plus 4y less than equal to 15. Okay, now we have to take these constraint, x plus 2y less than equal to 10 and 3x plus y less than equal to 15. Consider the equation 2x is equal to 10. X and y, we have to find the point. If x is 0, y will be 5. If y is 0, x is going to be 10. And we have to consider the equation of the second one. We have to find the points. If x is 0, y will be 15. And if y was 0, x will be 5. So the graph now we have to draw. We can take simple points. As we have got here 5, 15, we just take 5, 15, 20, 25. Only 4 are more than enough. Okay. So also we have to write the scale is very important while taking like this. Okay, we have to mention 1 unit is equal to 5 centimeter like that. Okay, now we'll take this 5, 10, 15, 20, 25. Okay, 5, 10, 15, 20, 25, 5, 10, 15, 20, 25. So the first point here is 0, 10 and 5, 10. So here it's going to be 0, 5. Okay, 0, 5 and 10, 0. And if we join these 2 points, this is the line formed by the first constraint. We have to write x plus 2y less than equal to 10. Then 0, 15, 0, 15 and 5, 0, 5, 0. Here we have to draw the line. If we draw the line here, this is going to be the second constraint. Now we have to see what is the region it is covering. So testing point origin 0, 0, 0 plus 0 less than equal to 10, 0 is less than equal to 10, which is true. And testing point here is 0, 0, 0 plus 0 less than equal to 15, 0 is less than equal to 15, which is also true. Therefore both are towards the testing point. This is like this, this is like this. So it is going to be like this. Okay, so we can clearly see this is the feasible region. So which is A, B, C and D. A is 0, 0, B is 5, 0, C we have to find, D is 0, 5. And to find C, we have to solve both the equation. X plus 2y is equal to 10, 3x plus y is equal to 15. Multiply the first equation with 3. So if you multiply, 3x plus 6y is equal to 30. 3x plus y is equal to 15. Subtract both the equations. So now 3x gets cancelled, which is 5y is equal to 15. Y will be 3. So if we have found y is 3, substitute in any one of the equations. Second equation I am substituting. 3x plus 3 is equal to 15. 3x is equal to 15 minus 3. 3x is equal to 12, x is equal to 4. Therefore, the point is 4, 3. The point here is C. C is 4, 3. So, we have got 4 points. So, ZA, ZB, ZC, ZD. ZA is 0, 0, 3 into 0, 2 into 0, which is actually 0. Then 3 into B is 5 comma 0. 5 plus 2 into 0, 15. And C is 4 comma 3. 3 into 4 plus 2 into 3, which is 12 plus 6, 18. And point D is 0 comma 5. 3 into 0, 2 into 5, which is actually 10. So we can see the maximum value is 18. So therefore the maximum value of Z is 18 at 4 comma 3. This is a very easy 6 marker and it is not much time consuming also. Within just 5 minutes, the maximum 5 minutes, you can solve this. Okay, and you have fifth question is minimize Z is equal to x plus 2y subject to 2x plus y greater than equal to 3, x plus 2y greater than equal to 6, x comma y greater than equal to 0. We have to show the minimum of Z occur at more than 2 points. So first constraint is 2x plus y greater than equal to 3 and x plus 2y greater than equal to 6. Then for the first one, equation is in this form, and if we have to find the points, if x is 0, y is going to be 3. If y is 0, x is going to be 3 by 2. We can also write it as 1.5. Next, x plus 2y is equal to 6. X comma y, if x is 0, y is going to be 3. And if y is 0, x is going to be 6. And we have to draw the graph now. Now, if we draw the graph, we can just take the simple points 1, 2, 3, 4, 5, 6. Okay, yeah. For that 1.5, we can just take from between 1 and 2, like exactly 1 point. At a 1.5 we can take. Okay, so 1.5, 2, 3, 4, 5, 6. Then here 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The first point is 0 comma 3 and 1.5 comma 0. Okay, now this is the line for the first constraint, which is 2x plus y greater than equal to 3. Then for the second one, 0 comma 3 and 6 comma 0. This is going to be the line for the second one. And then the testing point we have to take. So testing point is 0 comma 0 for the first one. So 0 plus 0 greater than equal to 3. 0 is greater than equal to 3, which is actually false. Then testing point for the second one is also 0 comma 0. 0 plus 0 greater than equal to 6. I'm writing here 0 plus 0. That is the reason is just because 0 into anything is 0. So we can just write that as 0. Okay, 0 is greater than equal to 6. So which is also false. Both are away from the testing point. So for the line 1, it is going to be like this. For the line 2, it's going to be like this. We can see there is no feasible region. Like there's no region which is intersecting. So for this, it will be like this. Okay. And for this, it's going to be like this. Okay. So therefore, the feasible region is actually free surface. Like there are only 2 points. It is a line. Okay. So we can only find 2 feasible points, which is A and B. The points are 6 comma 0 and 0 comma 3. Okay, we have actually found only 2 points, Z of A, Z of B. Z of A is 6 comma 0, B is 0 comma 3. Now substitute there. 6 plus 2 into 0 is 6, and then 0 plus 2 into 3 is also 6. Now both are actually the same, so therefore minimum of Z is 6 at 6 comma 0 and 0 comma 3. Okay, thank you for watching.